Hello everyone and welcome to Coding Cards. So in this tutorial we are going to solve one LeetCode problem. So you can see here the problem name is delete the middle node of a linked list. So here we will given one linked list and what you have to do here is you have to delete the middle node. For example, you can see here they have given one linked list having value 1, 3, 4, 7, 1, 2, 6. Here the middle element is the red marked one which is 7. So we have to delete this node. After deletion you can see here the output is 1, 3, 4, 1, 2, 6. And here they have mentioned like if the number of nodes are, let me explain you here they are saying that if n equal to number of nodes, for example n equal to 1 2 3 4 5, so my middle elements will be 1 by 2 2 by 2 3 by 2 4 by 2 5 by 2, and these values will be 0 1 1 2 2, and these are the index part. These are the index. Suppose here n equal to 3. If the nodes are 3, then we have to delete the element which is present at index 1. Suppose the number of nodes in the linked list is 5, then we have to delete the node which is at index 2. For example, suppose we are given a linked list having value 1, 3, 4, 7, 1, 2 and 6. 1, 2 and 6. So here the number of nodes are 1, 2, 3, 4, 5, 6, 7. Here n equal to 7 and n by 2 equal to, it will be 3. So this will be my index. So suppose the index values are 0 1 2 3 4 5 6. So we have to delete the node which is having index 3. So here index 3 is this node which is having value 7. So I have to delete this one because this is the middle element. So after deletion our list will look like 1 3 4 1 2 and 6. So they have printed the element like 1 3 4 1 2 and 6. You can see the output here 1 3 4 1 3 4 1 2 and 6. So this is the problem here. Let us take another example. Suppose one even number of nodes like 1 2 3 and 4 and 4. So here my n is having value 4. So n by 2 will be having value 2. So this is my index. So here the index values are 0, 1, 2 and 3. So we have to delete the node. Here node 3 is having index 2. So we have to delete this one. So after deletion, the linked list will look like 1, 2 and 4. So they are returning 1, 2 and 4 as an answer. So you can see here 1, 2, 4 as an answer. So this is the problem. Here we will be given one linked list, and what we have to do here is we have to delete the middle node. For example, suppose here we have two scenario. First will be the even number of node and second will be odd number of node. So let us check both the scenario. First for the even number of node. Suppose we are having a linked list having value 1, 2, 3, 4 for the even number, and let us take one example for the odd. So suppose the nodes are having value 1, 2, 3, 4 and 5. Now here my n is 4 and here my n is 5. So n by 2 will be having value 2. So from this linked list we have to delete the node whose index is 2. So suppose my index are 0, 1, 2 and 3. So we have to target this node here, and for this one also here n by 2 is having value 2. So here also we have to target the node whose index is 2. So 0, 1, 2, 3, 4. So we have to target the node whose index is 2. Means the count is 2. So this is my middle one. So how to solve this problem? So here we will be solving this problem using two methods. First one is using single pointer. and second method will be using two pointers. So let us first solve with using single pointer. So for example, suppose we are having a linked list having value 1, 2, 3, 4. Suppose we are handling first for the even number of nodes in a linked list. So what we will do here is we'll take one pointer, suppose p1, and p1 will be assigned with the head. So in this linked list, our target node is this 3. We have to delete this one. This is our target node because here n equal to 4 and n by 2 is having value 2, which is my index that needs to be deleted because this is the middle one according to this question. Now how this p1 will work? So let me write here, while p1 is not none, we have to reach till the end. While p1 is not none, so we have to reach till the end. While p1 is not none, we have to perform the iteration. So here p1 will move two nodes at a time. So once it moves two nodes, so its position will be here, so it will come here. It means p1 equal to p1 dot next dot next at a time, means it is working as a first pointer. Now once it moves two node at a time, what we will do, we will use one counter initially with value 0. We will add 1 here. Okay, so c plus equal to 1. Now p1 is here at index 2. Again it will go in while loop, and in while loop, while p1 is not none, yes, p1 is not none, p1 equal to p1 dot next dot next, p1 dot next dot next. Here it is having value none. Now p1 is showing to none. Now it will be updated with value 2. This is my final c value. Now see, again when it goes in while loop, here p1 is not none, but here p1 value is none, so it will come out of the loop. So when it's come out of the loop, see here we have the c value which is equal to the index value here 2. So we got the index value here. Now what we will do, again we will iterate in this linked list. Again we will point p1 equal to head. Again you start with the very first node, and what you do, while c is greater than 1, while c is greater than 1, you move one node at a time. Suppose this is 1, 2, 3, 4. We have to reach here, correct? While c greater than 1, why we are writing c greater than 1 means currently p1 is here, it means one node is already counted. Okay, that's why you have written c greater than 1. So here p1 will move, p1 dot next, p1 will move forward and c will be minus 1, c minus equal to 1. So c will be decreased by 1. Now it will move forward. Now p1 will move forward here, p1. Okay, and here c value was initially 2. After this first iteration, c value decreased by 1, so its value will be 1 now. Now here, while c greater than 1, no, c is having value 1. 1 greater than 1, this is false. So it will come out of this loop. It will come out of this loop. Now what is our target? Our target was to delete this node 3. So what we will do is simply move this p1 dot next to p1 dot next dot next. It will come out of this while loop, and we will write p1 dot next equal to p1 dot next dot next. So it will look like p1 was currently at the node 2. It is showing p1 dot next dot next. So p1 dot next value equal to p1 dot next value, this node you show to p1 dot next to next. So it will look like it is holding 1, 2 and 4. So see, we are done. For the even number of node, this logic is working. And also you know that suppose this is a linked list 4, 5, 6. Now suppose if you want to delete this node, in a single linked list, then you have to stand here. Then only you can simply write Suppose this is with p1, then p1 dot next equal to p1 dot next dot next. If you stay here, suppose you have to delete this node and you are staying here only, so you cannot delete this node. You have to just stay one node behind in order to move this next to the next dot next, so that this node will look like it is lost, it is not connected. So this logic is working for us for the even number of nodes. Now let us check for the odd number of nodes. Suppose linked list is having value 1, 2, 3, 4 and 5. Here my n value equal to 5, so n by 2 will be 2. So we have to delete the node whose index will be 2. So 0, 1, 2, 3 and 4. So this is my required node, these 3. Now suppose here we have while p1, so this is my p1 which is currently head. While p1 is not none, the previous logic. Here what we are doing, we are simply moving p1 equal to p1 dot next dot next. So it will move two node at a time. So p1 dot next dot next. So p1 will come here and currently c is 0. So c plus equal to 1. So c value will be increased by 1. Now again p1 is not none. So what we are going to do, p1 dot next. So it is moved to end node and c value will be 2 now. Now see here, p1 is at the end node. Now here after this it will again go in while loop, and here it is checking p1 is not none. Yes, p1 is not none. Currently it is at the last node. So in the next line we have written p1 equal to p1 dot next. So here in this line we will be getting error because p1 is at the last node. So suppose this is my last node p1 which is having value 5. Now p1 dot next is none, but dot next, this is not defined here. Till next p1 dot next is none, but dot next is not defined. So what we will do, it will give error. So to handle this one, what we will do, we will write one more condition here. We simply add here one condition, and this was for even number of node. So for the odd number of node, we will simply write a logic, and p1 dot next is not none. Then only we are going to perform this one. So now you can see here, this is for the odd number of nodes. Now you can see here, p1 is standing at the last node. Now see here, p1 is not none. Yes, p1 is not none, and at the same time p1 dot next is not none. p1 dot next is not none. This condition is failing since here p1 dot next is none. So it will simply come out of the loop. So till here our task is done. See, our required thing was we have to get this 2, the index value, because my n value was 5 and n by 2 will be 2. So we got the required value in our counter C. So after that we will write the same logic here. Again p1 equal to head, you move to first node, and again we will simply write while c greater than 1. While c greater than 1, because we are standing at the very first node, 2, 3, 4 and 5. We are standing here means we have already counted one node. While c greater than 1, what we have to do, p1 equal to p1 dot next, and c minus equal to 1. C will be decreased by 1. Now see here, c equal to 2. Currently we are here, c is greater than 1. Yes, move forward, p equal to p dot next is here, p dot next, move to forward, and c decreased by 1. So this value will be 1 now. Now you can see here 1 greater than 1, this is false, so it will come out of the loop. Now p1 is at node 2, at the required node. Since we have to delete this one and we are standing one node behind. Now you can see here p1 is at correct position. Since we have to delete this node, so we have to stay one node behind, so that we can write a logic like p1 dot next equal to p1 dot next. p1 dot next equal to p1 dot next dot next. You point to this node. So it will look like 1 is connected to 2, 2 is connected to 4, and 4 is connected to 5. So this is working fine. And at the end, we have to simply return head pointer. That's all for this problem. So this is the very first method. Let us write the code, and again I will explain you with one more example. So here, what is the very first task? We have to take one pointer p1 equal to head. After that, c equal to 0, 1 counter, and we will move forward with the help of p1 while p1 is not none. So this is for the even number of node, and we'll write p1 dot next is not none for the odd number of nodes. As we have seen here, the condition for the odd number of nodes. Now p1 task is to move two node at a time. So p1 equal to p1 dot next, and our c counter will be increased by 1. So we are done. So this while loop will execute till p1 reaches the end node. Now after that, what we will do? Now what we will do? We will again assign p1 equal to head pointer, means a start node. Now we will write the logic while c greater than 1. Now we are moving one node at a time with the help of p1. So p1 equal to p1 dot next. So it will move one node at a time, and c will be decreased by 1. C minus equal to 1. So till this c value is greater than 1, we are moving one node at a time, and whenever this while loop fails, it means we have reached the target node from where we have to delete the next node. So for that one, we'll simply write p1 dot next equal to p1 dot next. Means this while loop is for reaching the, let me explain here. The second while loop is for 1, 2, 3, 4, suppose 5. Suppose this is my linked list and this is my middle one which needs to be deleted. So for this one, we have to stand here so that we can write a logic like, here is p1. So with the help of this while loop, p1 is moving one by one and our c counter is decreasing by 1. So p1 will move from here to here. So when p1 moved to the next node, c value decreased by 1. C value became 1 now, and in while we were checking c greater than 1, but here 1 greater than 1, this condition is false, and here p1 has raised to the correct position, cause to delete this node we have to stand one node behind. So p1 has reached to its correct position, so that we can simply write p1 dot next equal to p1 dot next. So it will look like p1 dot next is showing to directly 4. So it will look like 1 is connected to 2, 2 is connected to 4, and 4 is connected to 5. So this is working fine. And at the end, we have to return the head pointer. So that's all for this problem. So we are done with the code. So let us run this code and check whether it is working or not. So you can see here it is working fine. Let us submit this code. Okay, so you can see here it is giving runtime error. Let us see what is the scenario for that one. Okay, we forgot to handle the boundary condition for the single node. So we'll simply write one if condition here. If head dot next is none. If it is none, then we are simply going to return the head. So we have forgot to handle the boundary condition here for the single node. Cause this logic will work for the linked list which is having the number of nodes greater than 1. Now let us submit this code. Okay, we are getting the wrong answer. Here you can see the explanation like for the single node linked list, they are expecting nothing, but we are returning the head node. So instead of this one, we have to simply return none. Now let us submit this code. So now you can see here it got accepted. So we have made a mistake here for handling the boundary condition. So that's all for this problem. So we have solved this with the help of single pointer, in which we have moved two nodes at a time, and we have used one counter for handling our condition. So I hope you understood this code and this explanation. So that's all for this problem. So if you like this solution, please do give thumbs up and subscribe to our channel Coding Card, and stay tuned for the next solution. Thanks for watching.